In this Theory of Computation tutorial, we'll look at how to minimize this DFA that has 4 states into this DFA that has only 2 states. So let's get started. Hey guys, welcome to another Theory of Computation tutorial. So let's begin with DFA minimization example number 3. So we are given this DFA over here. We have got 4 states A, B, C and D. Alright, now let's look at the problem. And before starting with finding out the equivalent states, let's look at all the states. As you can see, this is A is the starting state over here. We have got B and C which are final states. Okay, and we have got state D. But if you watch it closely, you can't reach from starting state to state D in any way. Okay, so let's say we go from let's use the pen. Okay, yeah, so let's say we go from state A to B, we can't reach to state D. If we go from A to B, B to C, we can't reach to D. We can't directly go from state A to state D, and there is no other way to reach state D. That's why if you can't reach state D, we will just eliminate this state. Okay, so if we eliminate this state, we'll get a new DFA that is going to look somewhat like this. We have got starting state A. Okay, you get input 1, you are in state A. You get input 0, you go to state B, and since state B is final, it is double circle. All right, then we have got state C over here, again double circle, and in state B if you get 0, you go to state C, and in state B if you get 1, you are in state B itself, and in state C if you get 1, you stay in state C, and you get 0, you go to state B. All right, so this is our new DFA. Any arrows or any connection related to D, state D, we are going to remove them, and we are going to remove state D because it is not reachable from your starting state A. All right, now we'll draw the DFA table, transition table for this new DFA over here. So let's say we have got starting state over here. Let's change the color. Let's use color green, darker green. All right, so we have got state A over here, we have got state B and state C, and inputs are 0 and 1. All right, so on getting input 0, you go to state B over here. State A is starting state, that's why this arrow, and state B and C are final states, that's why this star mark. All right, and in getting 1 in state A, you go to state A itself. What about state B? You get input 0, you go to state C. You get input 1, you are in state B itself. What about state C? You get input 0, you go to state B. You get input 1, you go to state C itself. All right, so this is our transition table for our DFA. All right, now the next thing that we are going to do is we are going to find equivalence of the states over here. Okay, so how do you find equivalence of the states? First thing first, let's write 0 equivalence. 0 equivalence. Now what is 0 equivalence? In 0 equivalence, you divide the states into 2 groups, one of final states, one of non-final states. As we can see over here, A is non-final, B and C are final states. So let's divide them into 2 groups, A in one group and B comma C in another group. All right, now what is one equivalence? One equivalence means when you give a certain input, is the output reached from both these states part of the same set or not? Okay, so let's look at an example. Let's, as state A, there is nothing to compare it with, we'll check equivalence of B and C. Okay, so let's say you are in state B. Okay, you get input 0, you go to state C. Is state C part of this set? Yes, it is. What about input state C? You get input 0, you go to state B. Is it part of this set? Yes, it is. That's why on getting input 0, they are one equivalent. What about input 1? So let's say you get input 1 in state B, you go to state B itself. Is it part of this set? Yes. What if you get input 1 in state C? You go to which set? You go to state C, which is part of this set. So it is part of the same set of states over here. That's why B and C are one equivalent. B and C are one equivalent. And since we have got 2 back-to-back same equivalent states, we'll stop over here. So as we have seen, state B and C are equivalent states. So we'll create a new state by combining them and we'll call it BC. Okay, so we have got input 0 and input 1, and we have got 2 states over here, state A and state BC. State A is the starting state and state BC is a final state. All right, so if you get input 0 in state A, as we know, we are going to go to state B, but state B is not present. Instead, we have got a new state called BC. So we'll write it as over here BC. What about input 1? You get input 1 in state A, you go to state A itself. And this new state BC, what you do over here, you get input 0 or you get input 1, you're going to go to state BC. Why? Because it is either going to go to C or B, but since both of the states are combined, we'll go to the same state, that is state BC. Okay, so as we have seen over here, we are going to the new state called BC. So what we'll do is just change the color red over here. Okay, and this new state is called state BC. Okay, now we'll draw the DFA for this. We have got input 0 in state A, you go to state BC. You get input 1, you go to state A itself. In state BC, you get input 0 or 1, you go to state BC. So this is how we minimize a DFA that had 4 states into a DFA that has only 2 states. Okay, so that's it for today, guys. If you have any queries, feel free to ask me in the comment section below. Thank you very much.